Hello everyone, very good evening and welcome to the BYJU'S Exam Prep, the most comprehensive app for all exams. Let me know that sound quality, picture quality, everything is fine. Yes, please inform me that sound quality, picture quality, everything is fine. Yes. Now you are on BYJU'S Exam Prep and we are going to discuss very important theorem that is called what? Norton's theorem, right? And already I have given some important assignments on Thevenin's theorem. So my dear students, this is a series where we are going to cover complete theorems from circuit theory, and this series is important for electronics, electrical and instrumentation branch. So let me know that sound quality, picture quality, everything is fine. Yes, please. I have to check this. Give me 1 minute. Yes, now everything is fine now. Please share the link of this session so that student will join, right? And now a very good evening, Hema. In this session we will solve important numericals on Norton's and Thevenin's theorem with independent sources as well as with dependent sources, right? So this is the Norton's theorem. This is a part 2. Already in part 1 we have discussed what Thevenin's theorem. Now this is my introduction. Myself Sanjay Rathi. I am having 21 plus years of teaching experience in ECE, GATE and PSU, and I have qualified and selected for engineering services exam. These are my rank: AIR 16 in ECE 2005 and AIR 21 in ECE 2008, and I worked as Deputy Director in Ministry of Power. Now watch this. This is a how to as GATE 2023 in first attempt. If you want to crack this exam in first attempt, then this is workshop for you. That is by Ashutosh Sir, your favorite. 8th May 2022, 12:30 PM. Please note this point. Register now. Install BYJU'S Exam Prep app on your mobile. Okay. Then, and that is in last session I have given assignments, and one student in comments box given the answer, that is the double R. यहाँ पर ट्रिपल आर होता तो अलग बात थी, लेकिन यहाँ डबल आर है, किसने दिया है? तो दैट इज द ऑप्शन. असाइनमेंट नंबर 1, दैट इज द 2 ohm, दैट इज द करेक्ट आंसर. असाइनमेंट नंबर 2 ऑलरेडी आई हैव सॉल्व्ड. असाइनमेंट नंबर 3, RTH is negative value minus 3.33. Yes, in some numericals we are getting negative value of RTH. I will explain why we are going to get the negative value of RTH. So that is a very well try by the double R, right? That is previous session Thevenin's theorem. And then assignment number 4, VTH is 100 volt. Assignment number 5, Rn is equal to 1 by 3 ohm. And all answers are what? Correct. If you are able to solve 5 numericals on Thevenin's theorem, means now you have the command over this topic, Thevenin's theorem, and this is very important topic for all competitive exams, especially for what? GATE exam. So that is the well try. So congratulations double R. Everyone, in every session I am going to give you the some assignments. Try to solve those questions and give me the answer on what? Comments box, and then I will mention your name on next session. Okay. Then now today I am going to discuss what? Norton's theorem, and then we will solve questions and as well as assignments. Okay then. So please share the link of this session. Now, what is the Norton's theorem? Simply a statement that any two terminal linear network with current sources, voltage sources and resistance can be replaced by an equivalent circuit consisting of a current source in parallel with the resistance, right? Current source in parallel with the resistance. So that is the diagram. Any linear network, like this is the point A, this is the point B, and that load resistance is connected here. we can convert this linear network into a single current source, that is called IN, Norton's current, and single resistance, that is known as RS or RN, Norton's resistance. This is also known as IS, across A and B. This is the terminal A and B. That is called Norton's equivalent. What is the IN? IN is called short circuit current. What is the meaning of this short circuit? Means simply get the network, and then make the terminal short circuit. This is the A, this is the B, and find the value of short circuit current. That is nothing but Norton's current. So first of all, remove the RL, make it short circuit, and find the value of the ISC. Then if you want to find the RN, in the previous class already I have given that this is the, first of all remove this, and you have to find the RTH. What is the RN or RTH? That is the seen at terminal A and B. We are having number of methods to solve the RN or RTH. In previous class already I have discussed. Again in this class we are going to solve some important numericals. Right then. तो चलिए, अरे ज़रा अब अपनी कॉपी पेन कैलकुलेटर स्टार्ट कर दीजिएगा. प्लीज़ ट्राई टू सॉल्व ऑल दिस क्वेश्चंस and share the link of this session in your group so that student will join the session. Okay. So now I am going to explain the Norton's theorem. So Norton's theorem, what is the Norton's theorem and so on. So first of all, that is the question on Norton's theorem, everyone. The Norton's equivalent circuit of the figure at terminal AB. Let this is the terminal AB. Already RL is removed here. And you have to find Norton's equivalent across A and B. Right? Means you have to convert this diagram into single current source and one resistor parallel to this current source, that is called RN, this is called IN. So what is the value of IN and what is the value of RN? Now this is a very tricky question. Okay, yes please, very good evening, double R. तो आपने दोनों बहुत अच्छा assignment बनाया. Already I have mentioned your name, right? You have given the answer for all the 4 assignments, right? All the 4 assignments and all are correct. I will discuss those questions, and in some questions we are getting negative answer, right? So RTH or RN may be negative, but watch this question. Here we are having only independent active sources. Independent active sources. If there is independent active sources, there is no dependent active sources. Dependent active sources means what? Voltage controlled voltage source, voltage controlled current source, current controlled voltage source, or current controlled current source. These are the dependent sources. If in a particular network, if there is no dependent sources, then we are not going to get what? Negative resistance, right? So what if only independent active sources? My dear students, all the resistance 8 ohm, 4 ohm, 8 ohm, 4 ohm, all are what? Positive. Okay. So all are what? Positive. We are not going to get the negative resistance. In case of dependent sources, if in a particular circuit, if there is a dependent source, then there may be a chance of what? Negative resistance. So what is the meaning of the negative resistance? I am going to explain in this session, but first of all try to solve this question. What is the answer? A, B, C, D. Give me the answer in comments box. This is a very simple question. Now, but here that is the beauty of this question. We are having the 8 ohm resistor here. 8 ohm resistor here. Now, to find the Norton's equivalent, always remember, we have to find the Norton's equivalent across A and B. Then, how we can find? First of all, always remember, if I want to take the reference, I have 2 choices, this one or that one. But always we are taking the reference at which point? Where more batteries are connected. So suppose, try to understand, let this is the B terminal and let this is the C terminal, B and C. So at C, 12 volt battery is connected, that current source is connected, 2 ampere current source is connected here, 12 volt battery is connected here, 4 ohm resistor is here. So normally which one is preferable? Where more active sources are connected. So here 2 active sources are connected, and that's why I am taking it as a reference. Now I am taking it as a reference, then I have to find the short circuit current here. First of all, make it short circuit. This will become ISC, and that will give you the Norton's current, right? When Vignesh, very good evening. Now try to solve this question. Everyone use your copy pen and calculator. This is very, very important question. And then once I am making it short circuit, what will happen? What is the current through the 5 ohm resistor? It will be 0. Means this current is ISC. Same current will flow like this, and this current will be ISC. You have to find the ISC. Means 8 ohm, this terminal and this 8 ohm are connected in series. Now you can take the voltage at this point is like Vx. You have to apply the KCL at Vx, and then you can find the value of ISC, because ISC will become Vx upon 8 plus 8. That is nothing but 16. Why? Because this will short circuit the 5 ohm resistor. Now how to find the Vx? Vx, what is the incoming current? Apply the KCL. Incoming current is 2 ampere. What is the outgoing current? Vx minus 0, that is Vx minus 12 divided by 4 ohm plus Vx minus 0. Directly you can apply Vx minus 0. How many resistor? 8 plus 8, 16. Right? Or you can directly write what is the outgoing current? ISC. And what is the value of the ISC? Vx upon 16. Directly you can write like this. Now 16, take the 16 as LCM, it will become 32. 4Vx minus 48 plus Vx. I am taking the 16 as a LCM. Then 48 plus 32, I think it is 80. Here 5Vx. Everyone tell me what is the value of the Vx? 80 divided by 5, that is 16 volt. That is the value of the Vx. Now what will be the value of the ISC? Vx upon 16. Short circuit current is nothing but Norton's current, that is 16 divided by 16. What is the answer? 1 ampere. Answer is 1 ampere. Sir, where active sources are more than, we should consider ground, no sir? Yes, yes. If the more than, where the more active sources are connected, then we are considering it as a ground or a reference node. This is the, like, no doubt we can also consider this as a reference node, but it will make the calculation lengthy, and that's why this C point is preferable. We are taking it as a reference. Here we are applying the nodal analysis, KCL, incoming current is equal to outgoing current, and that's why we are finding the ISC 1 ampere. Now these two answers are correct, C or D. Now how to find the resistance? How to find the resistance? It is simply the active sources. This will act as short circuit, this will act as open circuit. Remove this. Now here RN or RTH are, they have the same method. Now this 848, these are in series and 5 ohm in parallel. So what is the RN is equal to 5 parallel with 8 plus 4 plus 8, and the 5 parallel with 20, that is nothing but 25 divided 100 divided by 25, that is the 4 ohm. So Rn is equal to 4 ohm. That is the answer. Yes, Ram Krishna, your answer is correct. देखो सबके सब timely answer दीजिए. That D is the correct one. So my dear, what is the new in this question? What is the new in particular question? The new thing in this question is this 8 ohm resistor here. Because of 8 ohm, we have to decide which terminal, we can take which terminal as a reference. It may be or it may be, and I am taking this as a reference, and that's why I am finding the value of ISC and what, Rn, Norton's equivalent. Okay then, next question. Ready for the next question, everyone? Yes, please. Now try to solve this question, everyone. One question on dependent source. One question on dependent source. Then I will give you some assignment. Norton's equivalent seen at the terminal AB of the given circuit. What is the Norton's equivalent? कैसे निकालेंगे? What? How? यार लेकिन जरा एक बार इसे अपने ग्रुप में आप शेयर जरूर कर लीजिए, right? So that a student will join the session. Yes, please. बताइए, what will be the answer for this question? Right. Now, Norton's equivalent seen at the terminal AB of the given circuit. Now, in this case, we are having the negative value, negative resistance. If we are having the negative, is it possible? Then I will check and then I will solve the question that is given in assignment. Yes, this is the 10Ix, this is the Ix, this is the 1 ohm, this is the 4 ohm. It is here, it is a dependent source, Ix. Now, how to solve these questions? First of all, there is a dependent source, right? Okay, no problem. Now, watch this diagram. How to find the ISC? First of all, make it short circuit. That is called Norton's current. Now, this voltage, let's try to understand. Let this is the Vx voltage. What is the IXC? Let's take it as a reference. So ISC will become Vx upon 1 volt. This is the Vx upon 1. That is nothing but Vx. Now try to find the Vx. So here Ix, it is a dependent source, right? Because it is a current controlled voltage source. This is called current controlled voltage source. 10Ix, it depends upon the current. What is the current here? You can write the Ix is equal to Vx by 2. If the Ix is equal to Vx by 2, so what is the 10Ix is equal to? 10Ix is equal to, that is nothing but 5Vx. 5Vx. You can replace it by 5Vx. Now I apply the KCL at this point, that is nodal analysis. Vx minus 5Vx. Vx minus 5Vx upon 4 plus Vx upon 2 plus Vx upon 1 is equal to 0. From this, you are going to get, you are taking the 4 as a LCM, Vx minus 5Vx plus 2Vx plus 4Vx is equal to 0 because I am taking the 4 as a LCM, and you are going to get Vx is equal to what? 0. Because 4 plus 2, 6 plus 7 minus 5, 2Vx is equal to 0 means what is the Vx is equal to 0 volt. It is, there is no active source, no independent source are present in the system, and that's why what will be the value of the ISC or Vx? 0. Right? It is a source free. कोई source नहीं है इसमें. Are you getting this point? No active source, no voltage source, no current source. Right? And that's why output will be that 0, and therefore what is the ISC? V0. Now solve 5 to 10 questions, and after getting the confidence, you can directly give the answer for this type of questions. Okay, I think this concept is clear. Now what will be the, देखिए अब ये दो, these are the two options, A or B. Now which answer is correct? How to find the RTH? Because there is only dependent source, then I will connect a 1 volt battery here, and let this current is I. That is the Rn or RTH, that is the similar thing, 1 divided by I. 1 divided by I. Remember, if there is a dependent source, then this method will work. Connect a 1 volt external battery and then 1 divided by I. That will be the answer. Okay. Please try to solve this question. Now, this is the I. It is the incoming current. Okay, no problem. This is the Ix. This is what 10Ix. How to solve this question? We have to find the I. You can connect Vx here. Again, that is the second method, Vx here. I am just giving you the answer. Vx. Now, what is the Ix is equal to Vx by 2? Same thing. And that's why this 10Ix will become 5Vx. This is the 5Vx. Write down the KCL here. This time, Vx minus 5Vx. Vx minus 5Vx divided by 4 plus Vx by 2. Vx minus 0 by 2 plus Vx minus 1. Vx minus 1 divided by 1 is equal to 0. You can take 4 as a LCM. Vx minus 5Vx plus 2Vx plus 4Vx. Everyone, I am taking the 4 as a LCM. That will be the 4 is equal to 0. That is divided by 4. I am taking the 4 as a LCM. Vx minus 5Vx plus 2Vx plus 4Vx minus 4. Right? Now, that will become 0. Vx 2 plus 1 3 plus 4 7 minus 5 2Vx minus 4 is equal to 0. So what is the Vx is equal to? 4 by 2, that is the 2 volt. Okay. Now, what is the RTH? 1 by RL. 1 by I. How to find I? 1 minus, always remember, current will flow from higher potential to lower. So I. What is the value of I? 1 minus Vx. That will be the formula. 1 minus Vx upon 1. 1 minus of 2 upon 1. That is minus 1. We are getting the minus 1 ampere as a current. What will be the resistance? Reciprocal of this 1 by I, that is nothing but minus 1 ohm. In this case, we are getting the negative resistance. In this case, we are getting the negative resistance minus 1 ohm. Yes, please. Always remember, we are getting the negative resistance. Okay, no problem. Now, try to understand what is the method. If we are getting the minus 1 ohm, just watch this new concept here. Suppose we are getting the negative resistance. What will happen? For any circuit, if we are having the negative resistance, just I am giving you the value. Like, first of all, try to understand. If it is a 10 ampere, everyone give me the answer. If it is a 5 ohm, this is a 10 ampere current. Tell me, what will be the current through this 5 ohm resistor? This is the RL and this is the RS. According to current division rule, the current will divide it into 2 equal halves and the I naught will become 10 divided by 2, that is nothing but 5 ampere. Equally divided and that will become 5 ampere, right? Okay. Now try to understand. If this value is negative, then what will happen? Everyone, give me the answer for this question. If it is 10 ampere, this is the 5 ohm. Let I am connecting here. Everyone try to understand. Let this is the minus 15 ohm. Minus 15 ohm. This is the value of RS. That is the value of RL. What will be the I naught this time? If I am taking it negative. So I am going to use what? Negative value of the resistance. No problem. What is the current division rule? Total current divided by RS plus RL. If you want to find the current through the RL, it will be multiplied with the RS. Now try to understand what is the IS 10, what is the RS minus 15, what is the RS minus 15 plus what 5. Tell me what will be the current. What will be the current in this case? It will become minus 150 divided by what? Minus 10. Minus 150 divided by minus 10, minus minus cancel out, and the current is 15 ampere. Now what is the difference between these two diagrams? In this we are using the positive resistance. So output current I naught is less than what? Applied current. It means it behaves like what? Attenuator. The output current will be less than the applied current. It is a attenuator. It is a simple passive circuit. It is a attenuator, because that's why the current will decrease. But in second case, the output current is greater than what? Input current. Greater than, the magnitude of the output current is greater than the input current. Sometimes you may get negative value, but you have to check what? Magnitude. Magnitude is high, means this circuit is what? Amplifier. Amplifier. So always remember, if we are getting the RTH or RN negative, means this circuit is what? Part of amplifier. Or in case of part of amplifier, always remember one thing: positive resistance consume power. There will be the dissipation of the power across the resistor. But when the resistance is negative, it will deliver the power. And here the 10 ampere will deliver, RS will deliver, and that's why that will amplify the output. This will amplify this current, and that's why the output current will be more than the input current. Okay, I think this concept is clear. So this is a concept of what? Negative resistance. Achha, theek hai. In comments box, give me the name of any negative resistance device. You are from electronics, electrical and instrumentation branch. Give me any normal device which has negative resistance. Think about that and give me the name of that particular device. Now watch this. If in this case RS is exactly minus 5 or RL is 5, then tell me what will be the output current, everyone. Then I naught will become 10 into RS minus 5 upon minus 5 plus 5. Minus 5 plus 5, then that is what? Infinite. That is what? Infinite. Right? Because that is the cancel out, it will become 0. If the negative value, the magnitude of the negative resistance is exactly equal to what? RL, then the gain of the system will become what? Infinite. If the gain of the system will become infinite, what is the meaning of this? There will be the output without any input. There will be the output without any input. That is the reason. Yes. Yes, tunnel diode. Tunnel diode has negative resistance characteristics. Gun diode has the negative resistance characteristics. बिल्कुल सही है. Tunnel diode and gun diode, both are correct. So give me 1 minute. Yes, tunnel diode, बिल्कुल सही. Tunnel diode की characteristics, that is, we are having the negative resistance characteristics like this. In gun diode, we are having the similar type of characteristics. That is, in this area, we are having the negative resistance region here. This is the characteristics of tunnel diode. Drop across the diode. This is called peak point. That is called what? Valley point. This current is called IP. This current is called IV. And in this area, it will not follow the Ohm's law. And that is called negative resistance region. Okay. So when we want to make amplifier or oscillator by using the tunnel diode, then we are biasing the tunnel diode in negative resistance region. So are you getting this point? Now I am linking the two subject, network and what? Analog. Okay then. That is the answer. Tunnel diode or gun diode. Yes. Gun diode. Now time to solve the assignment questions. Yes, please everyone. What was the answer? Give me the answer. Then I will give you some assignments. Everyone try to solve those questions. That was the assignment. The answer for this question is what? Simply that is we are making it open circuit, that 1 ohm, make it what? 5 volt short circuit. 1 ohm and 1 ohm are in series. 1 ohm and 1 ohm are in series. When we are making it what? When I am making it what? 5 volt is a short circuited, that 1 ohm and 1 ohm are series, and this is the 2 ohm is the answer for this question. What is the resistor seen here? R, right? And that is what, this is disconnected circuit. The voltage between these two terminals, that is not asked across A and B, it is asked 2 ohm. One student have given the answer for this question, 2 ohm, very simple. Second question, the Thevenin's equivalent for the below circuit. That was the question. What was the answer? Everyone give me the comments. Thevenin's equivalent. Again, if there is only dependent sources, then what will be the voltage? Everyone, again already we have solved one question, because there is no external independent sources. There is no independent sources. What will be the value of the VTH? According to the concept, it will be 0 volt, but you can verify it. Right? This is the VOC. If this is the VOC, the voltage at this point will be VOC. What is the current here? 0. Write down the KCL. When I am writing the KCL, according to voltage division rule, what is the V0? That is ground. 20 divided by 10 plus 20 into VOC. That will be the value of VOC. That will become 2 by 3 VOC. Always remember, we can find from this point to this point, voltage is VOC. According to voltage divide rule, 2 by 3 VOC. And that's why it will become 0.5 V0 means what? 1 by 2 into 2 by 3 VOC. That is 2 to cancel, VOC by 3. This will become VOC by 3. Now, it is the, write down the KCL, it is the incoming current. What is the incoming current? VOC by 3. Plus, what is the outgoing current? Incoming is equal to outgoing. Incoming current VOC by 3 is equal to outgoing current. VOC minus 0, VOC by 30. My dear, this equation is only valid for what? 0. Is there any need to calculate? Is there any need to calculate this value? No. That is right. You can calculate 1 by 3 minus 1 by 30, that is equal to 0, and that's why VOC is equal to what? 0. No independent sources here. No independent sources, and that's why. But to calculate the resistance, yes, to calculate the resistance, again you can apply a 1 ampere current source or 1 volt battery. Yes, it's up to you. Suppose I am applying 1 ampere current source here. Watch this. You have to find the voltage at this point V. If you are able to find the V, then Rn or Rth will become V by 1. That is nothing but V. You have to find the V. V is nothing but the voltage at this point. According to current voltage division rule, V0 will become 20 divided by 20 plus 10. 20 divided by 20 plus 10 into V. 2 by 3 V. 0.5 V0 will become 1 by 2 into 2 by 3 V, that is V by 3. This is nothing but V by 3. Apply the KCL at this point. Apply the KCL at this point. What is the incoming current? 1 ampere. Watch this. This is the incoming current is 1 ampere plus what is the incoming current? V by 3. Incoming current 1 ampere, V by 3 plus is equal to what is the outgoing current? V minus 0 by 30. V by 30. That is the outgoing current at this point. This is the incoming, this is the incoming. I am writing the KCL at this point. Incoming plus incoming is equal to outgoing. Now this is 1 is equal to, you can write 1 by 30 minus 1 by 3. 1 is equal to, remember you can take the 30 as a LCM. It will become 10. It will become 1 minus, it will become what? 10. Please check my calculation. 9 by 30, and that is what is the V is equal to? Minus of 30 by 9, that is nothing but minus 10 by 3. Negative value. You are giving the wrong answer, Vicky. Please check your answer. Negative value. How many students get the same answer? Give me the comments. यार ऐसे नहीं होगा आप लोग अभी. Please try to give me the answer. Use your rough copy pen and calculator. You are going to get the similar type of question in competitive exams. And these are the methods how to solve the Thevenin's equivalent. Okay. So this is a negative resistance. V is nothing but RTH, and that is the method 1 ampere current source, and simply V by I, that is the V. You have to find the value. Minus negative value. Okay. बिल्कुल सही. Again negative, same logic. If we are getting the negative value, means amplifier. Zero. Now next assignment, this is the assignment number 2 or 3, I think. That is it is the assignment number 4. In the circuit shown below, the magnitude of the Thevenin's voltage in volt across A and B. What was the answer, everyone? Only you have to calculate the VOC, open circuit voltage. That. Try to understand. Give me the answer in comments box. This is the I and this is the I actually. That is the dependent source. If you want to calculate the VOC here, VOC is nothing but V1, and V1 is nothing but 8 kilo ohm into I. Always remember, if the resistor it is in kilo ohm, then current will be in milliampere. Okay? Okay. You have to find, that is the first equation. Then always remember, we can't write the KVL with what current source. We can't write the KVL with the current source, then we have to write the KVL like this. When I am writing the KVL, minus 75 minus plus 2 into I, that is the plus, this is the minus, plus 0.5 V1. 0.5 V1 is equal to 0. What is the V1? 8I, and that's why it will become 2I. This is the 2I plus 0.5 into 8 into I is equal to 75. Everyone, what is the I is equal to? This is the 4 plus 8.8, that is the 4 plus 2, 6. Sorry, 4 plus 2, 6I is equal to 75. So what is the I is equal to 75 by 6. 75 by 6. Now what is the VOC? 8I. 8 into I. 8 into 75 divided by the 6. That is 300 volt. 100 volt is the answer for this question. Very, very simple. Number of students are worried about what? Worried about the dependent sources. Sir, yeah, there are two dependent sources. Voltage controlled voltage source, current controlled current source. How to solve this type of questions? Very simple. Don't worry about the dependent source. There is a one independent source. That's why the VOC will not be 0. It may be negative, it may be positive. Now, second thing, right, this is multiplied with the 8 kilo ohm. Always remember, if I am having the current I, we can't apply the KVL here. This will become 8 into I. That is the VOC. Then write down the KVL at the input loop and find the value. And first of all, get the value of V1 in terms of what? I. Already we have solved the two dependent sources, and that is the method. Fourth assignment, and then 100. One student give me the answer in the comments box. Okay. That is the last assignment, and then I will give you the 3 assignments on what? From Norton's theorem. Try to understand. Find the Norton's resistance across the terminal AB. If I want the Norton's resistance, my dear students, always remember this RL, you have to make it what? Infinite. RL, make it open circuit. But what will be the silly mistake in this question? When I am going to make infinite, you will make this I is equal to 0. But always remember, this I is not 0. That is the good question from Sadiku, Alexander and Sadiku. Right. Then how to find the I? First of all, remove the RL. And because there is a dependent source 3I, you have to consider the small I. You have to consider the small I. Yes, there will be the session on what? Maximum power transfer theorem. We are here to cover what? Complete theorems. Thevenin's, Norton's. Tomorrow we are going to solve important numericals from previous year question paper as well as from the standard textbook. Then after that, I have session on what? Maximum power transfer theorem on Sunday. Right. Sunday we will discuss maximum power transfer theorem. Now, be careful about this diagram. Very, very important diagram. Right. When I am removing this RL, remember there is a II. So how to solve? First of all, this is the 2 ohm resistor. This is the 4 ohm resistor. This is the 3I, and this is the 4 ohm, and this is the 2 ohm. This is IX, but IX is not required because this depends upon the I. This is I. In this branch, there is a current I. Now it is act as open circuit. This is the terminal A and this is the terminal B. Always consider this. Now connect a battery here. You can connect a 1 volt battery. That is the method. And it will give the I current. Then what will be the RTH or RN? That is nothing but 1 by I. My dear friend, from this you can find I, or what is I is equal to minus I. You can write small I is equal to what? Minus capital I. Now you can write it like this, what? Minus 3 capital I. Because we have to find what? 1 by I to find the RN. Now this will become, this is the 1 volt, and that's why the voltage at this point will become 1 volt. You can apply the nodal analysis. This is the reference. Apply the KCL. What is the incoming current? This is the I is the incoming current. 1 by 2, that will be the 1 minus 0 by 2 plus 1 minus of minus 3i. Already I have replaced 1 minus of minus 3i upon 4. You can take 4 as the LCM. It will become 4i is equal to 2 plus 1 plus 3i. What is this? I is equal to what? 3. Tell me what is the 1 by I is equal to? RTH is nothing but 1 by I, that is nothing but 1 by 3. 0.33 ohm. 1 by 3, that is the 0.33 ohm. So what is the new in this question? That is the dependent source. So number of students will make the RL is equal to infinite, and that's why this II will become 0, 3I will become 0, and you are going to get the RTH is equal to infinite, or RTH is equal to what? 0. That is the silly mistake. That is the silly mistakes. And that's why this question I am giving 5 star to this question, because there is a chance of what? Silly mistake. Try to solve this type of questions from standard textbook, like what Sadiku or Van Valkenburg. That is answer is what? B. Okay. So ready for assignments? Yes, everyone. Are you ready for assignments? Yes. Try to solve the questions and give me the answer on comments box. Join my Telegram channel, that is Electronics by Sanjay Rathi. Already links are available, where I will upload the PDF of this session. Okay, and tomorrow we will discuss important numericals on what? Theorems. So that first assignment, everyone, please note the assignment. Yes, please. That is the assignment number 1. For answer, join my Telegram channel. Find the current I naught by using the Norton's theorem. Norton's theorem, you have to find the value of what? I naught, right? This is the I naught. Okay, and then try to understand, this is the A, this is the B. At this point, A or B, you can apply the Norton's theorem. First of all, 6 ohm, consider 6 ohm as what? RL. Remove this RL, find the Nortons across A and B, then connect 6 ohm resistor, and then find the value of what? I naught. Okay, give me the magnitude. Okay, then I naught. What is the current in this branch from this point to this point? I naught. You have to find the Norton's equivalent, and then second assignment. Right, this is the assignment number 2. The Norton's equivalent seen at the terminal AB of the given circuit. This is the A, right? Watch this. This is the A. This is the B. You have to find the Norton's across A and B. That is the 1 ohm resistor. Remember that. This is the 1 ohm resistor. This is the 3 ohm resistor. This is the 2 ohm resistor. And that is 4 ohm resistor. This is a 2 ampere current source. This is the 3 volt. Okay. Now watch this. You have to find the Nortons across A and B terminal and check the answer. Which answer is correct? Okay. Right. Next one. This is the assignment number 2. Assignment number 3. That current source is given as 4 milliampere. Right. Simply leave it. I will upload this question on my Telegram channel. Now this is a very one important question. Yes, that is on what? Dependent source. 2ix, 4ix. This is important. This is the assignment number 3. 2ix, 5 ohm, 10 volt, 4 ohm. Try to solve this question. Last one. This one. That is the assignment number 4. The Norton's equivalent circuit of the figure: 2Vx, 2 ohm, 2 ohm, 6 ohm, Vx and 5 ampere. You have to find the Norton's equivalent of this circuit. So how many students are interested to solve these questions? Now if you are going to solve these 4 numericals, then you are going to get the command over what? Thevenin's as well as Norton's theorem. Okay, and tomorrow we are going to solve important numericals from previous year question paper as well as from standard textbook. So ready guys, daily at 8 PM. Subscribe our channel, share the link of this session. You are on BYJU'S Exam Prep, the most comprehensive app for all exams. Thank you for attending the session. Thank you very much.